So as we start our journey into probability, we should probably start off with some definitions, words that we're going to be using a lot. So the first is an outcome. So an outcome, I mean, the definition says the possible result of a situation or an experiment. So for example, let's say I had a six-sided die, a little dice I'm going to roll, and I'm going to roll it one time, and I roll a 1. Well, that's my outcome. My outcome is a 1. Let's say that I'm not planning on rolling it once, but my plan is to roll it twice, and I come up with a 1 and a 4. Well, that 1 and a 4, those are both outcomes, but I'm going to call that an event. In fact, I could have called my first one an event also. So an event is kind of like outcome singular or outcome plural. An outcome is singular. And a really key term that we're going to run into a lot is a sample space. And a sample space is the set of all possible outcomes. So when I'm rolling my dice, my sample space are the numbers 1 through 6. Well, I would say the most simple kind of a probability is a theoretical probability of an event. And it's really nothing special. All it's saying is the number of favorable outcomes, the outcomes that I want, divided by the number of possible outcomes. So again, let's take our dice. I would like to know the probability of rolling a 2 on any given roll of the dice. Well, my favorable outcome is a 2, and that can happen one time in any particular roll. But the possible number of outcomes that I have is 6. I could roll a 1, 2, 3, 4, 5, or a 6. So my probability is 1 out of 6, and if I make that into a decimal, that is a 0.167 probability. So that's a theoretical probability, and we call it theoretical because we don't really need to roll the dice. As long as we can tell that the dice that we're rolling is a legitimate dice, it's not weighted in any particular way, it's pretty clear that each one of these options is equally likely, 1, 2, 3, 4, 5, or 6. Each one is equally likely, so we would have a 1 in 6 possibility, theoretically, of rolling any particular number. Another kind of probability is an experimental probability. And that's kind of a situation where, well, we don't really know what the likelihood is. It's not like a dice where it's all perfectly clear. There's 6 choices. There's going to be a 1 in 6 chance of each choice. It's something that we have to find out by experiment, by experience. Sometimes this is called an empirical probability. Empirical meaning something that comes from experience. So let's say, for example, I want to know the average size of, I want to know how many tuna in the sea are greater than 16 inches long. So I want to find that. That's how we write it. We'll show you how to do this in a little bit. I want to find the probability that tuna are greater than 16 inches. So I get in my fishing boat and I go out into the ocean and I catch 2,000 tuna. That's what I catch, and it turns out that 800 of them are greater than 16 inches long. So in that case, my event was I caught 800 tuna that were 16 inches or greater long, 800, and I'm dividing that by the total number of times I did the experiment, which is 2,000. So I can do a little bit of simplification here. I can have 8 over 20, which is equal to 4 over 10, which is equal to 2 over 5, which is equal to, in decimal, 0.40. So I would say that based on this particular experiment, And we would have to judge whether it was a valid experiment or not. But based on this experiment, my probability of catching a tuna greater than 16 inches would be 0.40, or 2 out of every 5 tuna that I would expect to catch should be greater than 16 inches. So even though I have theoretical probability and I have experimental probability, they're really quite similar. I look at the number of favorable outcomes, or the number of times the event occurs, and I divide that by the number of possible outcomes, or the number of times the experiment is done. They're really quite similar. Now, sometimes we give probability as a fraction. I have a 2 out of 5 chance, but most of the time, excuse me, when we're talking about probability, we give it as a decimal. And 0 probability is, well, it's impossible. It means whatever you're trying to find out, the probability, it's not going to happen. And 1 is the maximum. And really, the way I like to think about it is turn it into percentages. So I have a 0% chance of something happening, or I have a 100% chance of something happening. So the closer I get to 0, the less likely it is. The closer I get to 100, the more likely it is. And we express those as decimals. So 0 to 1, 0.6 would be about there. You kind of get the picture. So let's just walk through an example here. This example happens to be of a theoretical probability. I have a bag that has a bunch of crayons in it. I have, well, let's do them in color. I have 4 green. I have 1 red. I have 2 blue, B-L-U-E. And I have, I'm yellow, 5 yellow. I'm going to put yellow in black because yellow doesn't show up very well. 5 yellow. And I would like to know, what is the probability that if I pick one at random, that it will be blue? Now, notice the notation here. You're going to have to know this notation. I would write it like this. P for probability, and parentheses, blue. What is P blue? Well, there are 2 possible favorable outcomes, because I only have 2 blue crayons. So that's going to be my numerator. And my total possibilities are, well, let's add them up. 5, 7, 8. I have 12 crayons total. So that's the total, that's my sample space. So my probability is 2 out of 12, which is the same as 1 out of 6, which is the same as 0.167. I'd say that's a pretty low probability. And I would write it like this. I would write P blue, or P blue crayon. That's my event that I'm looking for, or my outcome, is equal to 0.167. So let's look at a different probability, another example. This one happens to be an empirical probability. We're basing it on some experience. And so here's a circular spinner. Let's put a little hand on it that'll spin around, right? You know how you flick it and it goes around? And it spins around, and we find out that after I spin it 12 times, it landed on section A 5 times, section B 3 times, and section C 4 times. I add those all up. I find out there were 12 times that I did it. Of course, I said I did it 12 times. And I'm trying to find out what is the probability of it landing on section D. Well, now, it's interesting. So let's do it the mathematical way. I can see that I had 3 favorable outcomes over 12 possible outcomes. So that's equal to 1 over 4, and I put it in decimal form. It is a 0.25 probability. Now, what's interesting here, that is my empirical probability. So P B is that. Now, looking at my little spinner here, if it was going to be a 0.25 probability, I would have expected B to probably look like that, to be exactly 1/4 of the spinner. We're not asking you to do it based on what the diagram looks like. We're asking you to base it on our experiment, on our empirical evidence. Because for all we know, the spinner could be rigged. So this is our empirical probability, and that's the way that you would calculate it. So for example, if you went to Las Vegas and you played a roulette wheel and you found out that one of the numbers came up really a lot more times than it should by a theoretical probability, but your empirical probability doesn't match with that, well, then that would lead you to do some additional investigation. I'm going to use this example that we just did to explain one additional term, and that is complement. Now notice that this is an E, it's not an I, so I'm not like giving you a compliment, although I would always like to compliment you. It's a complement, and what the complement does is that if I ask the question, what is the probability of not B? Well, based on this experience, I can see that if it landed on B 25% of the time, it's not going to land on B 75% of the time, so 0.75. So the way that you find the complement is you go 1 minus the probability of the event that you are finding out what it is not. So a complement is 1 minus the probability of the event that you don't want it to be.